This is y
Thank you.
value. So we have x values 1, 2, 3. Y values 4, 5, 2. You ready? Next, to calculate their relationship, how much they are related. What is their directions in relationship? Are they positive? When x goes up, y goes down, y goes, and when x goes up, y goes up and down. You gotta find out direction and magnitude using our coefficient. First, go to analyze. Ready? 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 Second, you go to, do you see correlate? In the middle right there, correlate. Ready? Do you see next little window box right there? Do you see bivariate? Bivariate? Bivariate. That means x and y. We have two variables to look at for correlation relationship. So you just click bivariate. Okay, that is the most common. Just click it. Good. Next, you gotta move variables that you wanna analyze. Then I wanna move x value, y value. Next, one of the most common popular correlation analysis is called Pearson moment product, PPM. So this is the default, so you don't need to check anything. Pearson. Okay, so now you're almost ready. Next, if you look at the bottom of this window, do you see flat? Significant correlation. This box is checked as a default. You don't need to touch anything right there, right? And I will explain what it is. Okay. Now you are ready. And we have candles, tau B, and also we have a Spearman rank order correlation right there. But I'm not going to cover this one. Okay, it's not really common. Once you are ready, click OK. And then once you click it, you will see a correlation table. Okay, correlation table right there. Let's see. Ready? Do you see Pearson correlation? Negative 0.655. Do you see it? Good. Almost R equal negative 0.66. So we just got the correlation coefficient between two variables, x and y. We estimated, well, maybe they have a little, the positive. Spss is telling us their relationship is positive or negative. Negative. What does that mean? When x goes up, y goes down. That's a negative. We have a negative. How strongly they are negative? 6.66. That means moderate. So you conclude the relationship between X. That could be exam 1, exam 2. The relationship between two tests is found with negative relationship and they are moderately related. Good? That's how you interpret this table. Negative 0.655. Any questions so far? Next, which is the most maybe confusing for you, 4 and 5. 4 and 5. Number 3, let's calculate their degrees of freedom. Here, n, listen, n means number of paired set. How many pairs do we have? How many pairs? 3 pairs, right? 3 sets. 1, 4, 2, 5, 3, 2. They are dependent on each other, correct? So we have n of 3. 3. So what is the degrees of freedom with this analysis? 3 minus 2 equals 1. Okay, that is the degrees of freedom. What if you have 50 paired number set? What could be the degrees of freedom? 48. Good? 48. Next, where do you put that information? Right there, that is from Chicago Writing Format APA, American Psychological Association format before you publish, present. Are parentheses. Inside the parentheses, you always put degrees of freedom. So our degrees of freedom is 1, parentheses, equals, so that means, yeah, you had 3 sets of data and you did correlation to find out their relationship, how strong they are, how strongly they are related. Are they positive or negative? We found out, yeah, the relationship is negative. And are they strongly negative or moderately negative? Well, they are somewhat strong, but a little bit over moderate, but definitely less than 0.8. So you can say moderately negatively related. That's how you interpret. So one on the test, you gotta report. What is the correlation coefficient? What is the degrees of freedom? What is their correlation coefficient? That will give you 2 critical information. The first part is the direction. Second part is magnitude. Good. So we're done with the number 3. Next, p-value. P-value. Sometimes even you got a little bit strong correlation coefficient. People will ask you, are you sure that we can trust your analysis? What is the possible error that you make to conclude that there is a negative, moderate correlation that you can tell? Please take a look at here. The next significance level, 0.546. This is also easily interpreted as the number of percentage of errors that you make. Errors. So here, yeah, there is a negative correlation boundary, but the possibility that I can make a mistake to conclude like that is 54%. 54% of errors. 54, 54, 54, 55%. 25. 55% of errors. How many of you will trust this relationship if there is 55% of error? Nobody, right? You're not really strong. Nobody will trust. So what is the level of trustworthiness? Then that is the p-value, probability level that you will make a mistake. So we already reviewed a little bit. 1 out of 100 error is 0.01. What about 5 out of 100? 0.05. What about 1 over 1,000? Equal 0.001. Those who are sleepy, please wake up, wake up, wake up. I'm trying to wake myself up too. I'm so sleepy, tired, right? So these are 3 most important p-value, probability value, okay? So those who will go to grad school, or maybe in the future, if you work in the analysis, analytical like a business, you will see P a lot. P. That means 1 of 3, okay? So first, 1 out of 100 mistake is written as 0.01. That means, what is the error rate? Only 1% of error, right? In other words, 99% is true, right? Correct? So you are 99% true, but you make only 1% right here. 0.546, 55% of errors. Do you trust? No. What about 0.01? Do you trust? Yeah. 5 out of 100, you are making 5 mistakes, correct? Then you are 95% confident. You are 95% true. 5% could be wrong. Good? Next, 1 out of 1,000, that is 0.001. You make 99.9% true. Good? Good? Okay, next. SPSS will give you one of these probability value by putting a star. 0.05, you will see 1 star. 0.01, 2 star. 0.001, 3 stars. Take a deep breath for 5 seconds. Ready? Ready? Okay. 0.01 means you're making 1% of mistake out of 100. 5 out of 100 is 5% of mistake. But you're still 95% true. 1 out of 1,000. That means you're making only 0.1%. 1 mistake out of 1,000. Right? But SPSS will not tell you, well, you got 1 out of 100. You got 5 out of 100. SPSS is not going to tell you their probability level to be true. In other words, the percentage of that you will make a mistake. Instead, they will give you a star mark. Let's take a look at our correlation table. Do you see any star? Do you see any star here, anywhere in this box? If you don't see any star, no stars means no stars means no meaning. You just waste your time to analyze. There's no relationship. There's no meaning to do such analysis. In statistics, instead of you try to be jargon, it said, well, that was insignificant. The correlation between X and Y is insignificant. I just waste my time, right? The reason is, well, the analysis is telling me, well, I might make 55% of mistake nobody will trust my conclusion. So I'm gonna stop right here. The correlation analysis was found insignificant. The reason was p-value probability that I make a mistake was greater than 0.01, greater than 0.05, greater than 1%, 0.001 level. Okay, so here, take a 5-second breath. P stands for probability that you will make a mistake. Probability that you could be true at a certain level. That's a P. Got it? Good. There are 3 different levels. 5/100. That is a 5% of probability that you will make a mistake. That is 0.05. So P equal probability is less than 5%. Do you take it or no? You take it, right? So you make a less than 5 mistakes. If you see p-value less than 0.05, then you need to conclude the relationship between x and y was significant. Then you conclude, well, at p-value of less than 0.05, the outcome was significant. Next, 1 out of over 100, that's a 1%. That is 0.01 level. Next, .001. So how many levels with the P do we have? 3 levels with the P probability. Which one is the most strict not to allow any mistake? The last one, right? The last one. If you were the owner of iPhone in a factory, you don't allow any mistake, errors, more than 1 out of 1,000, correct? Right? But what if you work at a Starbucks, you make a 5 mistake, you got misorders. I always order iced coffee, I always get hot coffee. So you gotta dump, right? The coffee you made. But they still allow you to make a 5 mistakes, correct? What if you make a 6 mistakes? You are wasting their materials, right? Then you are insignificant. Out, right? What if you make 4 mistakes? Even you are allowed to make 5 mistakes. You are more than significant, right? You are a good asset for Starbucks. What if you make only 1 mistake out of 1,000 orders? You are the superhero for that shop, right? The owner will love you. Well, you make only 1 out of 1,000. You are very strong. Your probability to make a mistake to make any ordered coffee is 1 out of 1,000. You are very, very strong. You are very, very significant. Right here, 0.54. What is the error rate? 54%, correct? So half of orders that you receive from your clients, right? Customers at Starbucks is wrong. Are you significant or insignificant? You're insignificant because you're making a lot of mistakes. So the owner said, well, you are insignificant. You are not really important. You are out. Then we don't report. Okay, we don't report if that is insignificant. Okay. However, let's change a few numbers and you will see